So on our left we have a scene, picture taken outside the building, and on the right we have student drawings. The big idea here, which few of you have yet grasped, is that when you see something, a scene like this that has obviously a set of horizontal lines, see, horizontal, 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 this is horizontal up here, even this is horizontal, then you can anticipate that what you're seeing is one-point perspective. And if you know it's one-point perspective, your first step should be to identify where you think the vanishing point is. And you can do that by extending any two orthogonals. The orthogonals are the lines that are not vertical or horizontal, and discovering where they meet. And if you do that with any two, then all the other orthogonals in the whole image can also be expected to converge at that point, which is actually on the wall in the back of the scene. Let's take a look at the picnic table quickly. Notice that it is creating a different vanishing point, and that is because the picnic table is at a slightly different angle than the building. Can you see that? But what you should be aware of, the most important thing about these vanishing points, is that they're at the same eye level. Both vanishing points correspond to the eye level where I was holding the camera when I took the picture. Okay, so when we look at these drawings, what we're looking for is, what happens if we try to extend orthogonals? Do they all meet at a point? And here we can see they don't, although these two are actually aiming for a point that is at the correct eye level. And that's part of what's good about this drawing. We're going to go through these quickly, and I'm not going to comment on the quality of the drawing. What I'm interested in seeing is what kind of vanishing point is implied by each drawing. And my screen, okay. So this is Braden, and this is really typical, Braden. You switch the direction of this, and you're implying a vanishing point that is about 20 to 30 feet off the ground. And in my years of teaching, what I've come to realize is that people imagine themselves 20 to 30 feet off the ground because it's a very useful place to think of the world from. It's useful to think of the world as a place we're looking down on, because if we think of the world that way, we're able to find our way around, right? We think of the world from a high vantage point, and that allows us to plan our next move within the world. So this is not unusual. Do you see how it really feels like we're looking down into this courtyard like from a drone or something, instead of being like really in it? Mark is implying a not quite as high as Braden, but this vanishing point that's implied is definitely towards the top of the wall, if not above the wall. So and this wall is about, I would say, 15 to 20 feet. So it's more of a slightly elevated wall. Can you see how even the picnic table orthogonals are aiming for a series of points clustered around here? Is this making sense, I hope, to everybody what I'm analyzing? It's really not. I'm not making fun of you. I'm just, it's just real, psychologically, it's really interesting to me, like why people do this. Kaylee, this is a really nice drawing. Amazing details and amazing consistency in your, like without, it doesn't seem like you marked a vanishing point on your paper, but in spite of that, you're really clustering, everything's meeting around the top of this building. So this again is a slightly elevated vanishing point. Can you see that? Like the actual vanishing point is about 6 feet off the ground, and yours is about 12 or 13 feet off the ground. But it's really amazing how, in spite of changing the vanishing point, which you can really tell you change it by, look at how much more this surface here is visible in the photograph than it is in your drawing. In spite of elevating the vanishing point, you've been amazingly consistent in your use of a vanishing point. Here's another solid drawing from Mila, and you are actually at about the right eye level, Mila. You're just a little bit over to the left. And the main problem is these two here are never going to converge. You see, these are parallel, so these are going to stay. They will never meet. So if you had just located your vanishing point in the right place about here, this could have been a perfect drawing. And Andrew, he was gaming while he was trying to do this drawing, but let's look at all we're interested in, Andrew, is where your implied vanishing point is. And if we connect these orthogonals, we can see that, and again, if we assume this building is about 15 feet off the ground, you're about 40 feet off the ground right now. Can you see that? Okay. Let's see. And let's see, we've got an orthogonal here. And this is an implied orthogonal, Abby. So, and this is also another orthogonal. You are sort of implying a vanishing point that's really one of the closest we've seen yet. Can you see that? It's like, and if you had actually marked your point here and started to use it to create these other orthogonals and a few verticals, can you see the drawing would have come together quite easily? Okay? And I know this is taking a while, but it's important. Okay, this is Elise, and whoops. Your vanishing point is way over here or here. So you are either way to the left or way above the wall, depending on which vanishing point we use. The main thing to see, Elise, is look at the angle of this line right here, and look at its actual angle. You have it almost horizontal, and it's actually more than 45 degrees slope, okay? And Ava, let's see, orthogonal, orthogonal, orthogonal. So Ava, you're a little bit to the left and also about 30 feet off the ground. Can you see that? Okay. This is, wait a second. Bella. So Bella, in 1-point perspective, a line that is horizontal has to be at eye level. So we can tell exactly where you think your eye level is. Your eye level is at the top of these pillars. So you also are about 30 feet off the ground. And again, the amazing thing is not that people do this, but how consistently they do it. Like, that's where people draw from. They look at something from 6 feet off the ground and they draw it from 30 feet off the ground. And it took me years to discover this, but it's just really interesting. And it's incredibly easy to overcome this problem once you learn to actually use the vanishing point. So this one looks very promising. Let's see, whose is this? Grace. So we're going to connect this one. That's a clear orthogonal down there. And you're clustering in a zone that's very close to the vanishing point, which is just pure. You're obviously not using the vanishing point, but your observational skills are good enough that you're really clustering around the right zone. Can you see that? So that's why this drawing really feels like it's drawn from the right eye level, even though a line like this is really way off point. And John did a really good job. I think this is purely observational because I didn't see John use a vanishing point. But let's see. We're going a little astray off here. You see that, John? And but you are, again, like Grace, just pure observational skills cause you to cluster your orthogonals in the right zone without actually, you did a great job on the picnic table. Look at that. You actually drew the picnic table better than the building. You used it really seems like you're using the vanishing point there. And also notice John did a great job of limiting his use of, in this area, to verticals and horizontals, which not too many people figured out. Like in an area like here or like here, all verticals and horizontals. And this is Hoshena. And I would say, I'm pretty sure you're implying a vanishing point that's way off the ground. So if we see where these two meet, Hoshena, and these two, and even the picnic table, you're converging things to, generally to a point somewhere above the wall. Can you see that, Hoshena? Okay. And a couple more. This is Tabitha, and look how many people made this line almost horizontal. So again, Tabitha, that implies that you're above the wall. These you also made pretty much horizontal, so these orthogonals are kind of all over the place. But you really have we do have a strong sense that we are looking down on this courtyard from a very high point. And John, almost exactly the same thing, John. Okay, wait a second. So you see see how high your eye level feels, John? You are near the top of the wall, and if we create orthogonals for the picnic table, we're even higher. You see that? And you made this, again, almost horizontal. So you're kind of all over the place, but all in that general area. And that's it. So get your new piece of paper, and those who joined late can draw with us this time. And here's what we're going to do. Let's see. So we are going to start by drawing the surface where we're going to draw this surface where we think the vanishing point is. So in the same way that when you are drawing your bedrooms, you're starting with the back wall, we're going to start with this wall, and we're going to say it's a square, and it's a little bit closer to the bottom of the paper than the top. And we're just going to draw that square. In elementary school, your teachers often make you use the entire sheet of paper, and that gets you into a habit of trying to compose all the way to the edge of the paper, which a lot of you did. See, you're trying to compose all the way to the edge. You don't have to do that. You could make this square even smaller than I drew it, and you can have a lot of extra space left over in your drawing, and then you can just crop it out at the end. I don't know why the elementary teachers are so hung up on not wasting any paper, but it's usually better to leave draw smaller than you think you need to, so you have extra paper left over. The next step is extend two orthogonals, any two, and I'm doing this on the screen, but you can do it by eye, just by holding you can like hold a pencil out in front of you like this, and see where the orthogonals are aiming. That works too. And discover the vanishing point. And notice it's about a third of the way from the left of the wall, and it's almost halfway towards the top. So that creates a vanishing point here. Once we have that vanishing point, we can draw these first two orthogonals like that. And notice that this one is cutting through the top of the wall at about the halfway point. Another way to think about this is that the angle is about, I would say, about 60 degrees. And if you remember what your 60-degree triangle looks like, 30, 60, 90, you see how this is about a 60-degree angle? So now I'm going to ask myself, where does this stop? And I could drop this down, and I could say, for one thing, I'm going to say this wall is maybe just a little bit wider than a square. And the interval from here to the vertical is about a third the width of this wall. So we're going to go about this far over and maybe a little further. And then we're going to go straight up. And that should get us to this point. Although I could check another thing. I can check the height of this wall. We call this height x. If we double it, we get to here. So we double it, we get to here, and this apex should be a little more than 2 wall heights up. So I might need to tuck it in. It seems like a little far. Just going to bring it in a little. So now that I found this corner, I can draw this shape up here. And I'm going to use a measuring technique. I think, have we done any measuring yet with pencils like this? Okay, so if you close one eye and hold your hand out in front of yourself like this, put the tip of the pencil at the top of the thing you want to measure and the bottom of your thumb at the bottom of the thing you want to measure, you can compare two things. And I'm going to show you on my drawing how that works. I'm measuring the wall like this. Tip of the pencil is at the top of the wall. My thumb is at the bottom. And then I'm going to compare the size of that wall to the size of this wall within the picture plane. Okay, so you're doing this. You can do it right on the screen, or if your arm is locked, you can do it from a couple feet away. And I want everyone to think about the answer to that question and tell me which wall is bigger and by about how much. So in the picture plane, is the brick wall bigger or is the metal wall bigger? Everybody? The brick wall is bigger. And it's bigger by about how much? By about how much? Anybody? Yeah, it's bigger by about 50%. Okay? So that means that the wall we're drawing up here should be about this big. So I'm just going to draw it that big. Now what you've just done is probably, and again, this is what we did. When we measured this, it was about 50% bigger than this. What we've just done is something that most beginning artists don't know how to do at all, which is to compare the relative size of things that are in different parts of the picture plane and at different distances. And the reason that's tricky is because we already estimated this wall is about like 12 or 15 feet high. This is like probably 3 feet high. Okay, so if they were in the same slice of reality and we moved this down here, it would be about this big, right? But because it's in a different slice, it's about this big. So we just used a relative size of things that are in different slices of the drawing, and that is something that's very easy to do once you know how and impossible if you don't know how. So now we've found this point, and we can go back towards the vanishing point like this. And I'm just going to draw that all the way down very lightly. And now we can draw this pillar. That's pretty easy because it sort of stays in front of this wall. It's about 2/3 of the height of the wall and 1/3 of the width. And it comes down a little past the bottom of the wall like this. Then we can draw the pillar that comes out of the top of this post. And once we have that, we can figure out where this surface ends, because it ends right above this pillar like that. And I'm just going to erase the construction lines to make the drawing a little easier to look at. And now we've got another column that's right next to this first one. It kind of overlaps that cement post. And we're going to draw that next. And in the picture plane, it is about 50 to 75% wider than this first one. So we're going to make sure to make it wider. And it terminates right about here. And we already know where this last column goes. Notice that you could fit about one column between this column and this column, so our spacing looks pretty good. And this, again, is about 50% bigger than the one behind it, so make it wider. And the top of it connects right up in here. And to find the bottom, we can actually use the vanishing point, because now we know where this corner is, and if we create a light orthogonal, we can find where this corner is. I think this exercise should be causing all of you to think about the problem a lot differently than you did the first time. Here's the vanishing point. Here's where another orthogonal starts. So we can just angle this towards the vanishing point like that. Another one, this one extends past here. There's another column way out here that on the outside edge of the picture. There is another orthogonal defining the bottom of these windows. And I'm going to say that the width of this metal square is about the same as the width of the window frame. See? So I'm going to go, this interval should be about the same as this interval. Once I find the interval, I can just go towards my vanishing point for these. There is a way to calculate this relative size of each one of these windows. But for now, what I'm going to do is just draw them. I'm going to make sure to get them closer and closer together as they go back. And we're not going to calculate it right now because I want to finish this. This is sort of the bottom of the building. So we've got another strip of windows here and another one here. And within those strips, we have a series of orthogonals going towards the vanishing point. Now we've got, having found this corner, I can go straight up. And there's a series of windows on this building. I'm going to draw this faint vertical. You really can't see them too well, so we're not going to spend a lot of time on them, but the bottoms of these windows all go to the vanishing point, as do the tops and the inside bars. Then to find this point here, what landmark can we use to find this height? Is there anything that we've already drawn that's going to give us a really good idea where this height is? Look at this. It's almost the same height, right? It's just a little bit. So if we go, basically, if we go from this height, take this orthogonal down, and then go straight over, that's about where the top of that building is. And then we go straight down all the way to the wall. And then we've got orthogonal here. And these surfaces are incredibly foreshortened, so we barely see them. It's going to be something like that, which was hard for most of you to conceptualize, that a building this big could be foreshortened into a space this narrow, but that's what you're seeing. There's another window back here that's all verticals and horizontals. It's okay. And there's the trailer over here. The path more or less goes to the vanishing point, like that. And the picnic table, as I said, goes to a vanishing point to the left of our original one. So I'm going to go ahead and sketch that really quick. And there's my door. There's Mason. For trees, I'm going to do a rough outline and then just do a quick first shading. And that's that. And this is what I mean about not trying to use the whole piece of paper. Now that I've done my drawing, I'm going to crop it. So this is the crop. And it's always so much better to have leftover paper than to run out of paper and not be able to show everything you want to show. So hopefully that was a lot easier. And I'm going to come around real quick and make sure everyone actually used their vanishing point. And hopefully you can look at this drawing now. You can do, while I'm checking them, you could just keep working on shading and details. And I think it's going to be a lot more satisfying than trying to do details on your first drawings, because everything's going to be so much more correct than it was the first time. And I'm going to stop my video now.